Good afternoon, friends, and thank you very much for joining us on this webinar where we want to talk about the use of biologicals and how to use biological inoculants with cover crops and some of the pieces that we have learned over the last couple of years. So the context for this conversation and this discussion, we have conducted many experiments over the last decade, testing and trialing various biological inoculants on growers' operations that we have worked with. And also, we've worked with growers who have wanted to try new products, try new tools, perhaps using compost teas. We've worked with growers who are producing their own compost tea, both compost tea extracts and with compost tea brewing. So we've had the privilege of observing many of the different products and many of the tools that are available in the field, and also observing what works more consistently than some of the products which perhaps work less consistently. It's been really intriguing that when we look at what is happening in the overall biostimulants and microbial inoculant product marketplace, there seems to be a different expectation of product performance as compared to, say, a biocontrol or to a fertilizer product, where with fertilizer products or biocontrol products, we expect to get consistent results and consistent performance. Every time we use something on a farm, we expect that product to perform the same way on this farm that it did on another farm 5 miles away or 50 miles away or 500 miles away in a completely different environment, in a completely different context. But that doesn't seem to be the case for microbial biostimulants. And so I wanted to talk a little bit about the pieces that we have observed that are required for more consistent performance and how we can improve product performance in the field. And then also speak a little bit about how we have worked to embody those principles and embody those ideas in the product called BioCoat Gold. So I have been, in the last month, was invited to participate in two different conference calls hosted by Ohio State University on selecting and using microbial inoculants. And I found the perspectives that were shared by many different people on the calls. They've pulled together a list of over 200 microbial inoculants that are available in the marketplace at this point, and described some of their characteristics. And they're trying to develop some general consensus for what are the important pieces to look for in selecting a product. How do you select a product? How do you know if a product has the probability or the possibility of being effective in your operation? And through the course of these discussions, I became quite intrigued with the broad array of different products that were available in the marketplace and how poorly it was described, how poorly the protocols were described for using these products effectively. So I wanted to discuss a summary of the pieces that we have observed in practical experience and observation working with these microbial inoculants and biological inoculants on grain crops over the last several years. All right, so just jumping right into this, what are some of the pieces that we believe are important for managing and working with biological inoculants? The first piece that I think is a very powerful piece, I believe that biological inoculants produced the greatest ROI of almost any product that a farmer purchases. They are relatively inexpensive on a per acre basis. They do not cost very much to apply. And consistently, we see that when you look at the yield response and the crop response, biological inoculants, generally those that work well at least, produce the greatest ROI of any application. They are more effective than foliar applications. They're more effective than nutrients applied at planting. They produce a tremendous crop response. And in my opinion, I believe every grower, every farmer needs to be applying biological inoculants at planting. In agriculture, there are many challenging decisions. about which products to apply, which to not apply, where the tipping points and where the thresholds are. Applying biological inoculants is not one of those difficult decisions. It pencils out very quickly and very easily on the farms that we have worked with. Another piece that we believe that is very important is that the most consistent, the most reliable inoculants contain a diversity of microbes. They contain a diversity of bacteria and a diversity of fungi. So of the 200 plus products that are available that are organically certified today, and even those that are not organically certified, there are many which contain one or two or three strains of bacteria or fungi. And there are a few of those. There are a few exceptions where sometimes a product which contains only a few strains can still be effective. For example, some of the rhizobium inoculants for inoculating legumes, or mycorrhizal fungi inoculants, where you might have a very effective mycorrhizal fungi inoculant that only contains 4 different strains of mycorrhizae. But aside from a few of those exceptions, those notable exceptions, for the most part, many bacterial and fungal inoculants perform the best when you have a diversity of strains and a diversity of different species contained within the microbial inoculant. And I would say the most successful products, or the most consistent products that we have seen, typically will have in excess of a dozen different strains. So we've observed products that will have anywhere from 10, 12, 15 strains documented to as many as 50 or 80 or more. And so when in general, just kind of as a general principle, we observe that the products which are tested and have been demonstrated to have a greater diversity of strains are the products which are most consistent across a broad variety of terrains and broad variety of environments. The third piece that we believe is very important is that inoculants should be partnered with microbial biostimulants. So today, there are a broad array of microbial biostimulants. These could be humic substances like humic acid, fulvic acid. It can be carbohydrates such as molasses or sugar, enzyme-containing products, ocean minerals such as sea crop. There can be a broad array of possible microbial biostimulants. We believe it is very important that a biostimulant be a partner with the inoculant itself. Finding a biostimulant that has a synergistic effect with the inoculant that we're applying can increase the performance of that inoculant by an order of magnitude, because it can help it get established and build a strong population. That's a very, very important piece. Another piece that is very important is that inoculants should contain both fungi and bacteria. So, for example, the 2 most common strains or species of fungi that are inoculated on commercial crops and on grain crops in particular would be various strains of mycorrhizal fungi and possibly in some cases trichoderma. So generally we see that you have a mycorrhizal product over here in one container, you might have a trichoderma product in another container, and then you have a bacterial inoculant contained in a third container. The most effective products that deliver the most consistent results are those that contain a combination. They combine the bacteria with the trichoderma, with the mycorrhizae, and they bring all of those pieces together so that, and because many of these bacteria and fungi have a very synergistic relationship, and there is a lot of value in having them combined in the field rather than applying them all separately at different times in different locations and places. The last piece is that consistency of performance is more important than yield response. You go, wait a minute, why is consistency more important than yield response? Well, microbial inoculants have an interesting characteristic in that they are extremely environment dependent. They're dependent particularly if these other pieces that I've been talking about, partnering them with biostimulants, partnering them using inoculants that have a broad diversity of strains, combining fungi and bacteria, those are all strategies to overcome the environmental dependency. But the reality is that these products and their performance is very much dependent on the soil environment to which they are applied. And because of that, these products have a very interesting characteristic. It's very pronounced, much more so than it is with a fertilizer product or with a biocontrol, which is that they can provide extraordinary crop performance and yield performance a small percentage of the time. And the majority of the time, they don't provide that same yield performance. So for example, on some of the inoculants that we've evaluated, that we've looked at, we might get as much as a 20, 30, in a few exceptional cases, even a 40% yield response. So it's an absolutely unbelievable crop response. It's an amazing crop response. But we only see that on 8 to 10% of the operations that try it. And the remaining 90% see absolutely nothing. It's not really a question of whether the inoculant was effective or has the capacity to be effective, because obviously in a few cases it does. It delivered exceptional results. But in many cases, it was really a question of the environment not being conducive to that inoculant propagating and expressing itself fully. So for this reason, the earlier strategies that I mentioned are all strategies to try to mitigate and prevent this from happening in the first place. But when you are evaluating a product to use on your farm, when you're speaking with the manufacturer, the question to ask is not what is the yield response or what have been the yield increases when you trial this product. Instead, the question to ask is what percentage of the trials that this product was used on did it deliver a yield response? You want to know how consistent that performance has been, because the more consistent the performance, the more likely the product is extremely resilient and will be able to deliver that same performance on your operation. Some of the challenges that we observe in agriculture and some of the reasons for using microbial inoculants are that one of the major challenges that disease-enhancing soils weaken the root system. And I'm certain I don't need to describe for you how a weakened root system expresses itself as the inability to absorb enough nutrients to fully fill the crop, and you get a substantial yield cut from weakened root system. The question is, what defines a disease-enhancing soil? So soil-borne pathogens are pathogens such as Fusarium and Verticillium and Rhizoctonia and Pythium and so forth that exist in the soil profile, and they are not dependent on plants, on living plants, on a host species. They can thrive and survive in soils for decades. Whereas the soil colonizing pathogens are pathogens that are completely dependent on a host. An example might be anthracnose. The pathogen is completely dependent on having that plant that it is feeding on or plant residue in the soil profile. The moment the plant residue disappears or the moment the plant disappears, that bacteria or that fungi can no longer survive and it's dead and gone. It's outcompeted by other organisms in the soil profile. However, this is not the case for all the soil-borne pathogens. So the soil-borne pathogens, Verticillium, Fusarium, and so forth, stay in the soil profile constantly. And you can, and they in fact, they stay in the soil profile as saprophytes. They are decomposers of non-living plant residue. They only express themselves as diseases and begin invading and infecting a root system when you have two conditions present. The first condition is when you have an unhealthy plant, an unhealthy root system for a broad variety of reasons that can trigger an infection. And the second is when you have what is termed a disease-enhancing soil profile. So disease-enhancing soil profile is purely an expression of the microbial community in the rhizosphere. So you can have a biological population that is in the rhizosphere, in the root zone, that strongly suppresses disease. And in fact, it can be so effective that it can suppress and completely eliminate any possible infection by Fusarium, both Fusarium root rot, Fusarium head scab on small grains, Pythium, Rhizoctonium, Verticillium, all these various challenges that can be major challenges on grain crops. So we want to switch this microbiome in the rhizosphere to be a disease suppressive soil rather than a disease enhancing soil. And developing a disease suppressive rhizosphere is a function of both bacterial populations and fungal populations. So this goes back to the piece that I was describing earlier, is that we really want inoculants that contain both of those pieces. Secondly, we need to have inoculants that support root system growth and development and really drive root systems. This is an awesome photo that I love. This was seed potatoes in relatively sandy soil. And so you have this basketball size mass of roots. And you can see that all of the soil is aggregating. Even though this is very sandy soil, we have very good soil aggregation, and it's sticking to the root system. This is because we have this aggressive and intense microbial population in the root zone. And this is one of the keys, one of the expressions of developing a disease suppressive soil. Some of the challenges that we have with some of the products that are available in the marketplace today is that in some cases, they contain only a few strains of bacteria or fungi. As I noted earlier, there might be a few exceptions where that is okay, as in with Rhizobium or mycorrhizae, but for the most part, you want to look at products that contain a diversity rather than just a few strains. Secondly, many products contain only bacteria or fungi. They are exclusively one or exclusively the other. There are a few products that can perform very well and can deliver nice results, but from my if we are truly approaching soil and plant ecosystems and managing the ecosystem from a systemic perspective, then we will want to use materials that contain both. They contain both bacteria and fungi. Another challenge is that many of these products perform inconsistently. So that's the one question that we want to ask is, what is the uniformity? What's the consistency of performance across all the various growers that are using this product? And lastly, many inoculants do not contain biostimulants within the product itself, and they need to be partnered with a biostimulant that is now a fourth product that might need to be added to the mix in addition to bacterial or fungal inoculants. A really strong inoculant should have all of these characteristics. It should contain bacteria that trigger mineralization processes in the soil profile and release soil nutrients. It should contain both bacteria and fungi that contribute to producing a disease suppressive soil. It should contain bacteria, particularly those grouped referred to as PGPRs, plant growth promoting rhizobacteria. So PGPRs actually produce plant hormones, cytokinins and others that they contribute directly to plants, and they lead to the production of very large, very aggressive root systems. So when you have these large aggressive root systems, you have the capacity to absorb a lot more nutrients later in the plant's development during the fruit fill period, where you have the reserve and the resources to fill a much higher yielding crop. Also, a good inoculant will contain bacteria which function as immune elicitors. So there are a number of bacteria which produce different compounds that serve as immune elicitors, and they trigger an immune reaction within the plant, trigger the jasmonic acid and the salicylic acid pathway. It's the equivalent of having a vaccination for the plant. So you tremendously boost and increase the plant's immunity and resistant to both diseases and insects in the soil as well as the upper parts of the plant. So containing these bacteria which are immune elicitors is a very important piece. And as mentioned, they should contain multiple strains of synergistic bacteria and fungi, and ideally also contain a biostimulant, whether that biostimulant be humic substances, seaweed, um, carbohydrates, various polymers, whatever the case might be, to really stimulate and develop a strong microbial population in the soil system, in the rhizosphere, very, very quickly. When we look at all of these different characteristics of what a good inoculant should contain, a number of years ago, we were making recommendations to the growers that we were working with. We need to use this bacterial inoculant, this mycorrhizae, this trichoderma, and let's combine it with this biostimulant product. So we'd end up having 4 different containers of 4 different products that farmers were applying. And this was a bit of a challenge, and it was frustrating to be able to coordinate all those pieces and make everything happen. So we asked the question, can we put a product together that contains all of these pieces within one container, that is easy for farmers to use, is very effective, and delivers the consistency of results that we're looking for? So we combined the best and most effective mycorrhizal fungi inoculant we could find, and the most effective bacterial inoculant that we could find that contained all of these various pieces, as well as others, and a biostimulant, and put all of them together into a single product. And that was the genesis and the foundation for BioCoat Gold. Growers are using BioCoat Gold today in many different ways. It was originally developed and intended for use as a seed treatment on corn, soybeans, small grains. And in that context, BioCoat Gold is being used on tens of thousands of acres today. It's very inexpensive. It's very easy to use as a seed treatment, and it delivers exceptional economic performance. But what we found intriguing, and I know this is a conversation for grain growers, but worth mentioning a little bit, what we've found intriguing is that fruit and vegetable crop growers are actually using BioCoat Gold in their irrigation systems throughout the entire growing season and reporting some quite extraordinary responses. So when we use it in grain crops, we expect to see all of these increased root biomass, increased plant health and vigor, increased yield, and all these various characteristics that a really good inoculant should provide, including nutrient release. One of the pieces that BioCoat Gold has been noted for is, in some cases, very substantial increases in phosphorus absorption and nitrogen utilization and nitrogen efficiency. This is actually also one of the big responses that was noted from the vegetable crop growers. When they started using BioCoat Gold in their irrigation systems, they got this tremendous phosphorus response. An increase in phosphorus absorption. This is a bit of a detailed graph indicating 4 plots out of several dozen where we tried BioCoat Gold and where we got a substantial increase in phosphorus absorption. So this is actually a graph of the phosphorus content contained within plant sap using plant sap analysis from crop health labs. And if you look across the chart, most of these crops have a median range somewhere in the neighborhood of about 300 to 350. This is all sweet corn, by the way. So somewhere in the neighborhood of 300 to 350 parts per million phosphorus in the sap. And that's about the desired range is about 400 to 500. So they are slightly deficient, except in the area where BioCoat Gold was applied. We have phosphorus levels ranging from 650 up to 900 parts per million. So these crops were able to get a very significant phosphorus response from the application of BioCoat Gold. And essentially, the 2 nutrients that we see the biggest crop response from most consistently in all environments are phosphorus and nitrogen. We also see some very nice responses with calcium and with calcium absorption in particular, but those really vary based on the soil's geological profile. So sometimes if we have soil types where there are calcium reserves that are available for mobilization, we get a tremendous calcium response. But where you have sandy soils or soils that don't have a strong calcium profile, we don't see the same degree of calcium response in the crop. In summary, we designed BioCode Gold to be a very easy to use package that combines all of these characteristics and that is very easy and very effective for farmers to use. And would very much like for you to use BioCode Gold on your operation. You can learn more about BioCode Gold at advancingecoag.com/gold.